I give the word to Philip, who will present the next paper. And you are from here, the Department of Space, Earth and Environment at Chalmers. Thank you. Welcome, Philip.
Thank you very much. So my talk will be on the industrial side. So in Sweden, which is typically a rather energy-intensive country with quite lots of natural resources, we have a strong industrial tradition, but also thereby quite high emissions from this sector. So this work was actually carried out as a PhD, part of a PhD program by Stefania Garðarsdóttir and supervised by me and Fredrik Norman. So she did the work. I'm just presenting it here. She's now working with SINTEF in Norway. And as Anders Lyngfeldt mentioned in his plenary here this morning, a good thing with the Nordic countries is that there is quite substantial storage possibilities around Norway and Sweden, in particular the North Sea, but also some in the Baltic Sea. So that's a good condition. Another feature is that many of these point sources of emissions from industry, also combined heat and power plants, are located nearby the sea. So it's fairly easy to apply ship transportation, which would be a preferable means of transportation, in particular in a ramp-up phase of a system, and also for public acceptance issues. I think it's good if you compare to onshore storage in Germany, where you know that has problems with that. And in the Nordic countries, we have a variety of various rather energy-intensive processes, including pulp and paper, which, as was mentioned before, is typically biogenic, of course, by its nature, but then a number of other industries. So in Sweden, I think this has been covered. There is a new target on this net zero emissions by year 2045, and there is also, that may not mention, this initiative linked to the Swedish climate framework is a Fossil-Free Sweden, which is a governmental initiative which tries to gather voluntarily industry to try to find ways to describe how they can commit to these targets. The aim of this study here was to assess, with focus on the investments cost of CO2 capture for main process industries in Sweden, using biogenic as well as fossil emissions. The methodology is that the emission sources were limited to those that emit 500 kiloton or more per year, because these account for more than 50% of the fossil-related emissions of industrial CO2 emissions in Sweden. And these emissions were derived from the EU emission trading scheme, and also from, with respect to biogenic, from a European pollutant release and transfer register. And we looked only at post-combustion, because it's makes the analysis easier. And the industry-specific design was derived from steady-state process modeling to get the required equipment size, and thereby be able to derive the cost, with main focus, as I said, on the investment cost, but also with a bit simpler estimate of the operational cost for these. So this is typically, you're probably familiar with the scheme for an absorber and desorber in a MEA amine scrubbing process, but also with this compression train scheme there to the right. And the cost estimations with the CapEx was made in different steps. So from the Aspen simulation, the different components were derived, of course, and there was used together with SINTEF a way to actually derive more the real cost in terms of everything from labor cost, installation costs, to number of pumps associated with different components and so on. And then there was also a scaling exercise to be able to cover all these emission sources. So with different the simulations were run for different flows and different CO2 concentrations in the flue gases, which were typical for these different plants that I was describing. The operational costs were only derived for 2 of these processes, the one with the highest, which was actually a power plant linked to a steel mill, and for the pulp and paper, and then it was extrapolated between there in terms of operational costs for the other processes. So when we look at these plants, we looked at 25 large point sources. So there was 1 cement plant, 1 chemical plant, 3 refineries, 19 pulp and paper plants, and 2 steel plants, including this combined heat and power plant linked to one of these steel mills. And as you all these are the ones that they're above 500 kilotons per year. And as you can see, Sweden is, like Finland, very strong, and we have a strong pulp and paper industry. So this sort of stands for the lion's share of the biogenic emissions from the industrial source. Then, as Fabian mentioned, there are also quite large combined heat and power plants for electricity and heat generation. So this is where they are located. So the green ones here are pulp and paper plants, steel plants here in Luleå and in Oxelösund, and chemical plant here, Stenungsund, and refineries here on the Swedish west coast. The brown here are transportation hubs derived in another project, the Nordics project, and these are possible storage locations, the Utsira formation, for instance, and this is the Falun and the Baltic Sea, and these were also used in another, so I'll come back to that in a minute. We first look at the capital cost here in mega euros. So this is mega euros, sort of with different flue gas flow. Obviously, a larger unit you will obviously have in absolute numbers a higher cost, although it's not linear. It sort of levels off a little bit, and it also, of course, depends on the flue gas concentration in the off gas. So this is for these different ones. So depending on how much flue gas you have and the concentration. And then here we have the specific cost, euro per ton CO2 capture, but no, it's only the capital cost versus the CO2 capture, and then you can typically, that's what one expect, of course, that the larger the CO2 capture, the relative capture cost will decrease, of course. And if we then look and add the ship transportation from analysis made by Jan Kjærstad, who's sitting there, one can see that this is the cumulative capex. So if we think about some sort of a ramping up phase, challenge for CCS is, of course, that the first projects will be more expensive because the share of the transportation costs will be higher. Maybe only one emitter has to rent the ship. But then, of course, as this can be coordinated and there is more, it'll be less of the total cost. We'll then look at the entire cost. So this is all steps: the capture, the transport, and the storage, including both investments and the operational cost. We can see that if we look at, and this is where the BECCS comes in here, so we can see that if we look at the fossil emissions, if we limit it to 500 kiloton, as in this study, we can only get this much, about 7 or so. No, sorry, it's not giving here, but I think we can only capture this much. This is the cost of, cost of CCS in euro per ton. So these are the dots here. So it's the average cost of these, and this is the marginal cost. and this is the CO2 capture capacity in megaton CO2 per year. So here is maybe 7, and these are the bars, so about 7 million tons here. So this is restricted. So if we want to keep to the fossil emissions and want to capture more, we have to go to smaller emission sources that will be more expensive, significantly more expensive. But if we also use the biogenic emission sources, that is from the pulp and paper industries, we can get this much, so about 16 plus million ton, and at a significantly lower cost then, because we can still be above these 500 kiloton per year. So this means that in Sweden, the conditions for biogenic or BECCS is very favorable, since we have a lot of biogenic emissions. Yes. Then, since this was brought up, or I guess this would be a discussion, and it's of course still, as was discussed both by Fabian and others, the cost for this product very roughly would be, say, 100 euro per ton CO2 to reduce the emissions to zero or emissions from these processes, where CCS is a big part, but then there are other measures required as well. So I just want to show, in relation to what was discussed, a way that we could look at this, and this is from another work actually, and so this is now the Nordic basic material industry, so it's basically steel and cement. So here is cement industry, this is steel industry, and if we sort of remove the emissions from these industries, it will cost them, say, roughly 100 euro per ton of CO2. And as you all know, these are under the emission trading scheme, which is now maybe 15 euro per ton, and after the revision it will increase probably, but still will be too weak for these rather transformative changes. So then I think the trick here is, and that was what I liked your table there, is I'm the first one to defend these whatever tax or this sort of classical EVTS, these classical trading schemes and so on. But if you instead recalculate these costs, so you do these measures, say 100 euro per ton measures, and if you recalculate these to the end product, in this case a building of concrete and steel, and in this case of a car then of CO2-free steel, the price increase will be typically less than 0.5%. So this is just showing that we have these different regimes, and so we think, as you mentioned, Matthias, that this could be a way to unlock this, to find ways to finance through, for instance, a fund for this with this product, because typically these businesses have very high turnover with billions of euros per year. So this is a possibility, we think. So if I conclude this, the Swedish government's climate framework for net zero emissions by year 2045 acknowledged the need for CCS from industrial sources, because it's really not possible for, particularly for instance for the cement industry, they really need CCS. For the steel industry, I should mention that in Sweden they are working on an alternative track with making steel from hydrogen. But it's a fairly long-term, maybe high-risk project. I think this work shows the importance and the possibility for BECCS in the Swedish conditions, because we have this large number of biogenic emission sources, and they are quite big, so we can then avoid targeting, at least within the next decade, targeting the smaller fossil fuel emissions, which eventually also have to be, of course, either decarbonized or equipped with CCS. During ramp-up phase, which I think is critical for CCS, the investment in the transport infrastructure is considerable. So that is a challenge, I think, to show. So of course, the best would be if you, Fabian, could pull up, I guess, with some other industries or other that wants to apply CCS to keep that down. And certainly if you want to go for pipeline transport, you really need an integrated transport and storage infrastructure. And then finally, I think in order to unlock this dead sort of or very slow development of CCS in general and BECCS in particular, we need complete different new ways to price the emissions. And I think that could come from bottom up when divestments from companies, and they will be care much more about their products, the carbon footprint of their products. You have to look at the entire value chain, not just focusing on the emission sources. So in that respect, this polluter pays principle is maybe not, we need something in addition to that, I think. Thank you.